Hi viewers, Assalamu alaikum. We are studying the dentin and our today topic will start from the dentin development. The figure shows the odontoblast differentiation and the next part shows the early dentin formation, the dentin pulp, predentin, amyloblast, enamel and the stratum intermedium. Life history of odontoblast. Differentiation of odontoblast. Figure shows the dentin, enamel, the basement lamina, endoplasmic reticulum, mitochondria, Golgi apparatus, and secretory vesicles. Here the arrows show the pre-amyloblast, the basement membrane. Arrow shows the cell differentiated from the peripheral dental papilla cells (UMC). These cells at first become short columnar cell with many stubby processes. Then the cell grow in the length approximately 40 micrometer and closely packed together. The figure shows the development of odontoblast along with the amyloblast. As the amyloblast grows in size, the odontoblast differentiate, then they become the short columnar cells and finally the cells grow in length. The cell body of the odontoblast is in the pulp area while the tubules extend towards the dentin. Odontoblast is differentiated from the dental papilla cells. The figure shows the odontoblast differentiation. Odontoblast is differentiated from the peripheral dental papilla cells. After mitotic division, some cells become differentiated while the others remain undifferentiated. The differentiated cells becomes the odontoblast. Histologic figure shows the enamel and dentin, the pre-amyloblast of the enamel and the pre-odontoblast of the dentin. The developmental enamel consists of the stellate reticulum, stratum intermedium, inner enamel epithelium. Basal lamina is also shown in the figure. The dental papilla, the predentin, also shows their direction of growth. Formation of predentin. Figure shows the large open-faced nuclei and the inner dental epithelial site. The odontoblast become a protein-forming and secreting cell. Rough endoplasmic reticulum, mitochondria, Golgi bodies, ribonucleic acid and alkaline phosphatase level increase. Formation of the predentin along the inner dental epithelial site. Odontoblastic process formation. The development is explained in the two parts. In the upper part of the figure, inner enamel epithelial cell is shown, which develops into the pre-amyloblast, then the developing amyloblast, and finally secretory amyloblast is shown. Cells of dental papilla develop into the developing amyloblast and then into the odontoblast. The cell body and the nuclei of odontoblast lie towards the pulp and the processes are extended towards the predentin and dentin. First, more than one processes of the odontoblast are present and then as more dentin is laid down, the cell recede and then leave single process called the Tom's fiber. The next figure shows the quiescent state of odontoblast. The odontoblast decrease in size and form dentin in a slowly diminishing rate until stimulated to form reparative becomes inocclusion. We were studying the dentin development and we have studied the life history of odontoblast, differentiation of odontoblast, formation of the predentin, and the odontoblastic processes formation. Finally, the quiescent state of odontoblast. Dentinogenesis. Dentinogenesis complete in two steps, matrix formation and the mineralization. Of matrix formation, predentin is formed. At first, the collagen fibers and the ground substance form the matrix and then the hydroxyapatite crystal results in the mineralization. Here the figure shows the direction of the enamel and dentin development. Structures explained in the figure are discussed earlier. Now we will study the steps of dentinogenesis and the number one was the matrix formation. Mantle dentin, the first formed dentin. Layer in the crown, the fibers are perpendicular to the dentino-enamel junction while in the root fibers are parallel to the basement membrane. Circumpulpal dentin. Fibers perpendicular to the dentino-enamel junction. The circumpulpal dentin, the fibers are parallel to the dentino-enamel junction, right or oblique angle to the dentinal tubules. Rounding of the cells and appearance of the junctional complex is also shown. Differences between the mantle dentin and the circumpulpal dentin. The thickness of mantle dentin is 10 to 20 micrometer, while the circumpulpal dentin forms the bulk of the tooth. The diameter of the collagen fibers in the mantle dentin is large 0.1 to 0.2 micrometer, while the diameter of collagen fibers The circumpulpal dentin is small, 0.05 micrometer. Direction of collagen fibers have right angle to the dentino-enamel junction and parallel to the basement membrane in the root, while the direction of the collagen fibers in the circumpulpal dentin have right or oblique angle to dentinal tubules, parallel to the dentin surface. Ground substance of the mantle dentin is formed from the odontoblast and the cell-free zone, while the ground substance of the circumpulpal dentin is formed from odontoblast. Mineralization of the mantle dentin is linear form, contain matrix vesicles, while the mineralization of the circumpulpal dentin is globular below mantle dentin that become mixed in the remaining circumpulpal dentin. The next step in the process of dentinogenesis is mineralization. The figure shows the budding of matrix vesicle, rupture of the matrix vesicles, and mineralization of the mantle dentin. Here, the figure also shows the budding of the matrix vesicle, rupture of the matrix vesicle, mineralization of the mantle dentin, has membrane rich in the alkaline phosphatase, calcium and phosphate ions undergo crystallization. The matrix vesicle is shown in the figure. Now the pattern of mineralization. Figure shows the matrix vesicle in the matrix, the crystallization process, the lodgement of the crystals, and finally the rupture of the matrix vesicle. The pattern of mineralization is linear at the mantle dentin area, globular in the circumpulpal dentin just below the mantle dentin, combination in the remaining circumpulpal dentin of the crown and root. Thank you so much for watching the video. Don't forget to subscribe the channel.